Welcome to a new lesson. In this lesson and the next one, we would learn how joins can be applied on MapReduce framework. Joins is an operation where we combine two or more datasets based on a column or a set of columns. At this point of time, I'm assuming that you are aware of different types of join, that is outer join, inner join, equal joins, etc. All these can be applied in two ways in MapReduce framework. First is the map side join, and second is the reduce side join. Both of them have their own pros and cons and should be applied only to specific scenarios in which they fit in. While map side join is more efficient in terms of speed, on the hindsight it has a lot of constraints on the scenarios where it can be applied. The reduce side join is more flexible of the two and can be applied to almost all the situations, but is comparatively slower than the map side join. In this lesson, we would study about map side joins. As well, before we start, I would like to mention that joins are fairly complex to design in MapReduce framework. In Java, it would take you easily to write hundreds of lines of codes with complex design. And you can do the same thing in higher level frameworks such as Pig and Hive in just 5 to 7 lines. Although one advantage of using Java solution is that it is highly optimized solution in terms of processing speed of the data. But optimization is not very significant when put in light with the ease and speed of development of the solution. So it is highly recommended to use Pig or Hive for join operations, and you would see in practice in that ways. But still, let us have a look at how the solutions are designed and what is map side join. This would build an overall understanding of the MapReduce framework. So let us take an example. Of course, we are considering a very small dataset just to understand the concepts that can be applied to very large datasets. Here let us assume we have a dataset which shows the billing details of employees to the projects with project number, employee ID, rates in dollars per hour for employee, and hours that are billed by the employee on that project. Now let us say we have another dataset which has project details like project ID, project name, and the budget. Let us assume that we want to combine these two datasets on the basis of project ID and see all the project details and employee billing details together. Now in map side join, map operation would produce this output result. Later we can use reduce phase to sort the dataset, or we can as well choose not to use the reduce phase at all and just run it with the map phase itself. So looking at the diagram, you can guess that the map will have to have the input data in the following form so as to produce the shown output result. So now looking at this, we would be able to infer the strict requirements which should be considered while thinking of MapReduce join as an option. First and most importantly, all the input datasets should be sorted by the same key, and that should be the one based on which the join is going to be performed. Furthermore, each input dataset must be divided into the same number of partitions. All the records for a particular key must reside in the same partition. As you can see that here the key is the project number, and it is important for the map to have all the data records from both the input datasets for a particular project number present at once. Then only it would be possible to correctly join the two datasets. Now all these would seem to be very strict requirements and very difficult to attain, but these all fit the bill of the output of the MapReduce job. If both the input datasets have gone through the MapReduce job with the same key used at the time of partitioning and the number of reducers used are the same, then the output would be produced with firstly equal number of partition, secondly each of the datasets would be sorted by the key, and lastly, all the records pertaining to a key would be present in a single partition. So whenever you see map side join logic applied, it would be in the MapReduce job chain. In the next segment, we would learn about reduce side join, which is much more flexible of the two.